Hello, this is the first in a series of videos on parabolas, and this video particularly pertains to parabolas with the vertex at the origin. I have this picture down here just to illustrate that a parabola is defined as a set of points that are equidistant from a focus and a line that's called the directrix. So all of these points on this parabola, they're equidistant from the focus and the directrix. So when we're characterizing parabolas, we need to have that information. We need the focus and the directrix. It's useful, and the vertex. It's also useful to have a couple points on the parabola, and we'll take a look at points on the latus rectum, which are points that are perpendicular to the axis of symmetry at the point of the focus. Okay, so standard formulas. These are just for parabolas that have a vertex at the origin. We have y squared is equal to 4px. I like to think of this p is associated with the variable in which we're moving along that axis to get to our focus. So in this case, if p is greater than the 0, our parabola is going to open to the right. If p is less than 0, it's going to open to the left. And when I say that this p tells us how far we have to go to get to our focus. So our focus is going to be at p0. So we move from our origin to p along our x-axis. And the directrix, we're going to move opposite, equidistant opposite to get to our x equals negative p. Now our latus rectum, we're going in this drawing, our vertex is at negative 4, 0. We're going to move up 2p and down 2p. So we're moving perpendicular to our axis of symmetry to get to our latus rectum. So it becomes p 2p and p negative 2p. If we have x squared is equal to 4py, this is kind of like the standard format that we're used to seeing. Like in algebra, we see a lot of x squared, y is equal to x squared, or y is equal to x squared x, a squared, ax squared plus bx plus c. That's sort of the quadratic formula. We're used to seeing parabolas in the x squared form. So when p is greater than 0, it's going to open upward. If p is less than 0, it's going to open downward. Again, from our vertex, we're going to move along our y-axis to get to our focus. So our focus is 0p. And we're going to move in the opposite direction an equal amount to get to our directrix at y is equal to negative p. Again, the latus rectum is going to be the endpoints of the line that bisects the parabola that is perpendicular to our axis of symmetry through the focus. So our focus was 0p. We're going to move 2p in 2p to get to one endpoint and negative 2p to get to the other endpoint. Okay, I have a link here. This is a website, and I really liked, when I was looking at this stuff, I really like this table. It has our formulas up top, so if you're a formula person, you can use this. And if you're, it also has the pictures with the formulas put in it, but it's really useful to, I'm very graphical, so the bottom part of this is I really like, but I know some people really like the formula. So if you like the formula, you can take a look at the top. So if you want to pause this and just take down this website, I found it useful. Or it's also, some of this stuff is in your book as well. So let me just go back here. Okay. So let's take a look at some examples. We have this example that is x is equal to negative 12y. So I've just copied down here what I have from the other page. We're in this format of x squared is equal to 4py. So we're going to be opening upward or downward. So our 4p in this case is equal to negative 12. So if we divide both sides by 4, we get p is equal to negative 3. So our vertex is at 0, 0. It's in this format with no pluses and minuses. And we're going to move negative 3 to get to our focus. So our focus is here. So our focus is at, again, 0p, 0, negative 3. We're going to move equal distance in the opposite direction. So up here to 3, this y equals 3 line is our directrix. Okay? So now technically we have everything that defines this parabola, but to draw it, we like to have some more points. So the easiest points to find are the endpoints of our lattice rectum. And remember, this was 2pp and negative 2pp. So we're going to move 2p is 6. We're going to move 6 and negative 6 from our focus to get to the endpoints of our lattice rectum. So we have this point here at 6, negative 3, and this point here at negative 6, negative 3. So now we have some minimal amount of information. We can draw this parabola. And I'm sure you can do better on your paper than I can do on my screen, but that gives us a rough idea about what this parabola looks like. Okay, so our vertex is at 0, 0. Our focus is at 0, negative 3. We have the endpoints of our lattice rectum, and our directrix at y is equal to 3. I'm going to clear these drawings, and we'll take a look at a parabola with an x-axis of symmetry. So this y squared is equal to 8x. So the first thing that we want to do is we want to find out what our p is. So 4p is equal to 8. So our p is equal to 8 divided by 4, or 2. So we know our vertex is at our center. We're going to move in our, we have this here, p is greater than 0, it's going to be opening to the right. We're going to move along our x-axis, because our x is with our p, to get to our focus. So we're going to move 2 to get to our focus. This is our focus, is at 2, 0. And our directrix, we're going to move 2 in the opposite direction. So we have our directrix is here at x equals negative 2. Okay, and now we want our 2 endpoints of our lattice rectum. P is 2, so 2p is 4. We're going to move up 4 from our focus and down 4 from our focus. So we have these points that are 2, negative 4, or p, negative 2p, and p, 2p, which is this 2, 4 point. So we can, again, we have enough points to kind of roughly sketch this. Okay. So whenever we're given an equation, we want to identify which way it's opening based on our format, and if p is positive and negative. We want to find our p so that we know how far we need to move to our focus and to our directrix. We want to plot our vertex and find the endpoints of our lattice rectum. That gives us enough points to get a rough idea about what this parabola looks like. Okay, I'm going to clear this out. Take a look at this. Sometimes we are given, we aren't given an equation, we're given points and we're asked to find the equation. So if we have this equation, I like to sketch this out. It helps me. If you can use all formulas and do it that way, that's fine, but I find this useful. We have this focus is a 0, so out here is our focus. We have a directrix at x equals negative 8. This is our directrix, x equals negative 8. This is 8, 0. So we know we're moving 8 in equal direction. We know our vertex is at 0, 0. We know our p is equal to 8. And because we kind of get an idea like this, we're opening to the right, we're going to have something that looks like, y squared is equal to 4px. So we know what p is, so we can plug it into this equation, this standard format. Y squared is equal to 4. We said p was 8x. So y squared is going to equal to 32x. If this wasn't focused, if this wasn't centered at the vertex, we'd have to find the distance between the focus and the directrix and divide it in half and move that distance to find our vertex. This is clearly equal, negative 8 and 8. The middle of that is 0. But if it was something else, if they weren't equal and opposite, then we'd have to do that. But that's how we do this. There will be another video on parabolas that are with vertexes that have been, or parabolas that have been translated from the origin, so the vertex will be someplace else. So if you have questions on those, take a look at that video.